In this section, I'm going to show you another example of using an access list. I'm going to use this inside a route map. I'm going to use that route map for policy-based routing. This is not the best practice, of course, to drop messages using a policy-based routing route map. I'm just showing because I want you to know that this is possible as well. So let's go to router 2 first. First of all, I want to make sure that there is no access list here, nothing. What I'm going to do is to create an access list that permits all ICMP messages. I am permitting these ICMP messages because I want to make sure that this access list matches all of those ICMP messages. This is not going to deny them. It is just being used by another procedure such as a route map. So I can use an IP access list that is a named access list, or I can use a numbered access list based on your preference. So this is going to be, for example, ICMP messages, or better to say ping messages. That's a better idea. Pings. And I'm going to match this like this. Permit ICMP any, and that's going to be equal to, or no, that's going to be echo. Now hit enter. This is the access list that I'm using. Now I'm going to use this inside the route map. The route map is PBR, and inside this route map I am matching this access list using match IP address pings clause. I can have more matches, such as match interface, and that's going to be the interface that these messages come in. That's going to be serial 10. And I can match another criteria, such as the length, or let me see what I can match. I can match using ASPAT. These are for BGP. Community. This is again for BGP. Interface, the incoming interface for the message. I can go with length. I can check the length of the message. I mean, how many bytes are this? I can go with metric, or I can go with route type. These are for OSPF or EIGRP. I can match with tags. A lot of items are here to match with. So these two are good. So whatever message I receive with this criteria, I'm going to drop it. The first, the best way to do this is to set interface to null 0. Null 0 is an interface that that is like a discarding interface. Whatever you forward to null 0, it's going to be discarded. That's it. Now I'm going to use this under serial 10. So if I go to interface serial 10, I can use IP policy command and match it with a route map, and the route map name was PBR. But before applying this, I want to make sure that pings are working. If I go to router 1 and try to ping 100, 100, 100, 100, ping works just fine. If I go to router 4 and try to ping this, you can see again ping works just fine. Of course, not this IP address. I should go with this. Now you can see that from outside I can reach inside, from inside I can reach outside, but whenever I apply this route map to interface router 2, if I go to router 1, ping works because I dropped only echo messages that come from outside. But if I go to router 4 and try the ping, you can see the ping doesn't work because it is sending echo messages that get stuck in this interface, because there is an access list that permits them, and there is a route map that sets the interface to null 0. So everything is getting discarded on router 2. What about other types of messages? I just used echo messages. I just filtered echo messages. So if I go to router 4 and I initiate another ICMP message such as trace 10 10 12 1, that's going to be successful. So only one type of messages filtered, and that's a good approach.